Hello everyone. I hope everyone is well versed with the question and they have already read the problem provided. This is the example that LeetCode has provided us with, right? We have 4326 within these indices, and we have to calculate for every rotation. We have to calculate a f of k value, right? There is no rotation in this particular array. This was the example provided. So we calculated f of 0 to be 4 into 0 plus 3 into 1 plus 2 into 2 plus 6 into 3. Quite simple, right? 4326. Now what we did in the first rotation, we rotated the array. So what happened was 6 was at third index, but now it came to the zeroth index. 4 was at zeroth index, but now it came to the first. 3 was at first index, it came to 2. 2 was at second index, and it now became um an element at third index, right? So 6432 for this particular arrangement. Now we calculate f of 1 value, right? So f of 1 was calculated like this: 6 into 0, 4 into 1, 3 into 2, 2 into 3. Now we know this particular problem. Now we know that this particular problem has n value. The limit of n value is 10 to the power 5. So we know that this has to be calculated in big O of n only, right? So we'll have to observe a pattern so that we can find the maximum of all the f of k values, right? So I can observe from here that when I'm rotating, what I'm doing is the element that was at the last index has to now become the element at the zeroth index. So when f of 1 is calculated, the contribution that the first element is doing is nothing. First of all, it was contributing n minus 1 time, n minus 1 times, right? It was contributing 3 times. We can check from here that 6 into 3, n minus 1 times it was contributing. But now in the next iteration, it is contributing nothing, right? It became 6 into 0. Okay. And for the other elements, we can observe that 4 was contributing 0 times, but now it will contribute 1 time. We can see 3 was contributing 1 time, but now it will contribute 2 times. 2 was contributing 2 times, but now it will contribute 3 times. This means that except the element that is now at the zeroth index, every element, every element's contribution was incremented by 1, right? 4 became 1, 3's 1 became 2, 2's 2 became 2's 3, right? So the next value that we calculated for f of 1 was somehow related to f of 0, because now if we claim this particular value to be equal to previous, so now this value became previous minus 6 times 3 plus 4 plus 3 plus 2. How? Because the element that was at the last index was now at the zeroth index. So initially it was contributing 3 times, but now it's contributing 0 time. So we can write this particular value to be previous meaning this particular value, f of zero's value, right? So f of 1's value became previous plus 4 plus 3 plus 2 minus 6 times 3. How? Because 4 plus 3 plus 2, all these elements were now contributing one more time than the previous. They were now contributing one more time than the previous value. And 6 was contributing 3 times, but now it is not contributing. So the next value is going to become previous plus all the indexes that are not at the zeroth index minus minus 3 times the element that is now at the zeroth index. So we can observe from here that 4 plus 3 plus 2 can also be written as total sum. 4 plus 3 plus 2, 4 plus 3 plus 2 can also be written as total sum minus the element that is at the zeroth element, right? Because all the elements that were not at the zeroth index are now contributing more, right? So previous is total sum minus zeroth element, right? Which is this particular value, total sum minus zeroth element. And 6 is contributing nothing here. Then it was contributing 6 was contributing 3 times here, but now it's contributing nothing here. Likewise, we calculate for 2643. Now a previous value has become equal to f of 1, right? And now we are calculating f of 2. So we can see that 2 is now here and other elements indices have been incremented by 1. So the same pattern is being observed here. 643 were contributing 0, 1 and 2 times respectively, but now 643 would be contributing 1, 2 and 3 times respectively, means one more than they were contributing before. We can see 6 into 1, it was 6 into 0 before. 4 into 2, it was 4 into 1 before, and likewise, right? And the element that was at the last index is now contributing nothing, right? So it was contributing 2 into 3 times, but now it's not contributing. So the next previous value is going to become previous minus 2 times 3, right? Minus 2 times 3 because it is at the third index, minus 2 times 3 because now it's not contributing anything, plus 6 plus 4 plus 3. So 6 plus 4 plus 3 can also be written as total sum minus the element that is now at the zeroth index, right? Similarly, so we know 3 is now become the zeroth element, and 2, 6, 4 are incremented by one index, right? So 3 is now not going to contribute anything, so the previous value is this and the next value is this, so minus 3 into 3 will do, and we'll simply add these values, 2 plus 6 plus 4, right? So basically we can observe a pattern here and calculate that first of all 4 was a zeroth element, so we calculated f of zero's values and named it as previous. Now we are going to calculate f of 1 value. We know that the last index has to become the zeroth element. So when we are at I is equal to 3, 6 into 3 is going to be subtracted from the previous value, and 4 and 3 and 2 are going to be added. In other words, we can say 4 plus 3 plus 2 to be equal to total sum minus 6, right? The element that is becoming 0 here. And for the next iteration, we'll have I is equal to 2. So I is equal to 2 means now that the element that is coming at the zeroth position is 2. Okay, so we'll calculate likewise that 2 is going to be decremented 3 times. Why 3 times? Because this is the case when we are considering 2 to be rotated next, 2 to be given the zeroth index next, right? So we'll do minus 2 into 3 plus 4 plus 3 plus 6. Then for the next iteration, 3 is going to become 0. So we'll do 4 plus 2 plus 6 minus 3 times 3. That was what we were doing here, here, right? So and then we'll also likewise calculate the max value. So let's just check out the implementation part. First of all, n is the num sort size, then we have previous initialization and total sums initialization. We iterate our array and we calculate the previous value to be indexed into nums of I and add all those values. This is the f of zeroth value that we calculate. First of all, 4326, for 4326 it was 4 into 0 plus 3 into 1 plus 2 into 2 plus 6 into 3. So we calculated previous value. Also side by side we calculated total sum to be plus equal to nums of I, right? And now we initiate answer to be first of all previous. Okay, because answer is basically the maximum of all the previous values that we get. Then we iterate in the array backwards. Why backwards? Because we know that the for the first time 6 is going to become zeroth element, then 2 is going to become the zeroth element, then 3 is to become the zeroth element. So we calculate previous value to be what was previous before plus the total sum minus nums of I. Note here the nums of I here is basically the element that has to become 0 currently, that has to become zeroth element currently. So total sum minus nums of I minus nums of I into n minus 1. Because in the previous value, we were adding nums of I. Nums of I was a last element. but now it has become a zeroth element, so its contribution is going to be nullified, and total sum minus nums of I is to be added, because the other elements now shifted their position by one indices. Okay, so we calculated the answer as well here, because answer is going to be the maximum of all the previous values, and we returned the answer. And we can say that a time complexity was a big O of n, and a space complexity was big O of 1, f of 1.